In this video, I will talk about Upwind method. The motivation to study Upwind method is as follows. Suppose we have 3 points, 3 grid points. This is j, j plus 1, j minus 1. And this is the center of these 2 grid points, which is j minus 1 half, and then we have j plus 1 half. And these two are the uh, uh, between these two midpoints is a cell number j. This is called the cell j. So suppose that the information over wind, for example, wind is traveling from left to right. So it is more obvious that you should focus on the left hand side. If someone is standing over here, he or she can see the wind from that side. So it means that the information is more important on one side, one-sided, uh, one-sided direction. So that is actually the motivation of upwind method, that you just focus on left-hand side either if the velocity of the wind is greater than zero, the speed is greater than zero, or if the speed is negative from right to left, then you should focus on that side. So that is the one-sided operation in upwind method. This is all the motivation of upwind method. So for example, if someone is sitting over here, then he or she can see that this will influence j only. It will not influence the j plus 1. Since the information will travel first on these 2 grid points after passing through the gate of this cell. Now we talk about the mathematics. Suppose we have an advection equation, partial q by partial t plus u bar partial q by partial x is equal to 0. This is our equation number 1. What we see that if the information is traveling from left side, for example, I have I minus 1 half, this is I, this is I minus 1, so on. So if the information is traveling from left side, so it means that what is entered over here, the quantity is entered is I minus 1. So at time level n, I minus 1 will enter from here. And when you talk about the flux, then you need to multiply this with u bar. This flux will enter from the left side. So we have Fn I minus 1, I minus half is equal to u bar and the approximation of qn I minus 1. Remember that qn I minus 1 is approximately, it is an approximation of q, which is our exact solution, Similarly, if you talk about the flux on the right hand side, I plus 1 half, suppose we have I plus 1 half over here. Now all the information is, since the information is from left to right, the information is left to right, either it is a velocity, it is a pressure, it is a density, whatever that quantity is. On I plus 1 half, you calculate the flux over here. The flux that will exit from this I plus 1 half is this quantity. This quantity will be at nth level n, and this is I. So we can get the flux on I plus 1 half due to the left point, the left side on I plus 1 half, since there is nothing over here. So we have, for example, u bar qn and I over here, and remember that Q and I is it is an approximation of Q. You can obtain the flux on I plus 1 half by just replacing this function of Fn with I plus 1 minus 1 half on both sides. You can see that we have I plus 1 minus 1 U bar Q and I. And on the left hand side, we have Fn I plus 1 half. So simply you can obtain the second flux from the information of first flux, and the physical interpretation is given over here. You must know the physical interpretation as well, how the information is traveling from here. So our numerical method will be, or maybe first I write the numerical method in the flux form. Qn plus 1I is equal to Qni minus delta T by delta X, and we had Fni plus 1 half minus Fni minus 1 half. So we first need to define the flux. We already did that for the Upwind method by physical reasoning. We can put that value over here and the next value over here. So we get Qn plus 1 I is equal to Qni minus, and the flux is U bar delta T by delta X, and that will be equal to, I'm sorry, we just have to replace the flux. What is traveling to on the flux? It is Qni minus Qni minus 1. So here you can see that we have one-sided flux. We have one-sided value. You must say it. I must say that this is one-sided value. It is coming from I and I minus 1. And we assume that U bar is greater than 0. Since why? How should I know that this is U bar is greater than 0? Since the points involved in calculating the flux are I and I minus 1. So this is I and this is I minus 1. So information must be traveling from left to right. And when you have involved I and I plus 1, so it means that the information must be traveling from right to left, and U bar must be less than 0 in that case. Okay, so this is what we have over here with some assumption that U bar is greater than 0. We can rewrite this numerical method as follows. We can write this as follows. Remember that it is always not true that you must be given Q. You must have been given, for example, some other variable as well. So in that case, you need to write this formula for U n plus 1 I and so on. You have to change all the variables in your numerical method. So let me just rewrite above equation in the following form. So we can write, for example, Qn plus 1I is equal to Qni minus U bar delta T by delta X, Qni plus U bar delta T by delta X, and we have Qni minus 1. So we combine the values, similar coefficients, 1 minus U bar delta T by delta X, and that is Qni plus U bar delta T by delta X, Qni minus 1. Or here you can see that we have, for example, Qn plus, or maybe I have that This is CFL number, so I can write it 1 minus C Qni plus C Qni minus 1. So the new value is the weights of 1 minus C and C. So there are two possibilities. Either if when C is 0, it means that U bar delta T by delta X is equal to 0. Then we have U bar delta T is equal to 0. Then either you can divide delta T 0 by U bar, which means that there is no step, or you may say that U bar is equal to 0 from here. In that case, for C is equal to 0, there is nothing happening. So we have, for C is equal to 0, we have Qn plus 1i will be equal to Qni. The old value will be equal to the new value. When C is equal to, for example, 1, in that case, we have U bar delta T by delta X is equal to 1. And from here, we can find out the step. What step should we take? That will be delta X over U bar. So in that case, we have Qn plus 1i, then we have Qn I minus 1. So in that case, the value will be the next value will be coming from Qn I minus 1. So if, for example, you see that it is I, this is I plus 1, this is I minus 1. When we had C is equal to 0, so the new information is coming from this value, which is at nth level Qni. And when we have C is equal to 1, the new information is coming from Qni minus 1. Okay, so that's how we write the numerical method and interpret it. Let me just uh, write it differently, some another way, to explore how it is different than another method. So our numerical method is Qn plus 1, Qni minus U bar delta T by delta X, that is Qni minus 1. So that is the numerical method. We rewrite it as Qn plus 1 Qn minus U bar delta T by delta X Qni minus Qni minus 1. So I divide both sides with delta T, I'm sorry, Qn plus 1i minus Qni divided by delta T. Then we have, and I take the right hand side on the left side, we have delta U bar Qni minus Qni minus 1 divided by delta X is equal to 0. So our equation was partial Q by partial T plus U bar partial Q by partial X is equal to 0. Previously, in previous video, you have seen the flux which was unstable, which was FTCS, forward in time, centered in space. For the advection equation, it was written like this: Qn plus 1 Qni divided by delta T plus U bar Qni plus 1 minus Qni minus 1 divided by 2 delta X is equal to 0. So here we have upwind scheme, and here we have the centered scheme over here. So here U bar is greater than 0, and the purpose of this comparison is of upwind method and the center scheme is there is a slight modification which follows the uh, physical situation. And here from previous thing, we can see that the value of C should be 0 to 1. Okay. If you could have, for example, if U bar is less than 0. Now I am talking about the stability, okay? So then we have Qn plus 1 I is equal to Qn I minus U bar delta T by delta X. In that case, the information will be coming from Qn I plus 1 minus Qn I. Okay, so I write it as Qni minus U bar delta T by delta X Qni plus 1 plus U bar delta T by delta X Qni. Let me just check that either this is the correct uh, numerical method. So I plus 1 half, and then I have I plus 1 and I. So information is coming from I plus 1 and so on. So it is correct. Okay, so I just take a common 1 plus this quantity is the CFL number minus C Q and I plus 1. In that case, you can see that we have when C is equal to 0, you have Qn plus 1 is I is equal to Qni. When we have C is equal to minus 1, so we have Qn plus 1 I, and we have Qni plus 1. That's where the information is coming from. So it means that C should be uh, between minus 1 to 0. And previously it was so let me just summarize that. If U bar is greater than 0, so the C is from 0 to 1. When if U bar is less than 0, so C is minus 1 to 0. So the C is minus 1 to 1 for C for U bar, either it is greater than 0 or less than 0. Okay, and that's what we have probably seen before. The C, the current number, should be less than or equal to 1 in general, either for positive velocity or negative velocity. Okay, so this was all about the upwind method. Thank you for watching.